So for this last lesson, we're really focusing on a couple different things of aspects of graphs. We're really kind of pushing this whole graphing thing. So let's take a look at one and let's see what we can do here. First off, I just kind of want to notice a couple of things that I look at when I take a look at graphs for the first thing. First off, we have h and we have t. And this is going to be our dependent variable. And then, of course, we have our independent variable. Just going to sneak it in right there. And it's saying that we have h is a function of t. So it's saying that our height is a function of t. A function of t. It's a function of t there, okay? So what's interesting about this question is that we have height, we have time. That's our dependent and our independent. We have our variables, and we additionally have our units. We have minutes and we have meters here. There's a couple things that we want to make sure that we know about. First off, these are some pretty important points that we're going to be describing, and that's this point right here and this point down here. And we call these intercepts. Intercepts are pretty huge in mathematics, and there's two types of intercepts. There's going to be the x-intercept, and this is where we have a line or a coordinate that intercepts the x-axis. So it's a point on the x-axis. And then we have the y-intercept. And the y-intercept is exactly the same, except on the y-axis. Point on the y-axis. In our next unit, this y-intercept becomes something that is very, very useful for us when we're making equations. And in further units, in higher grades, 11 and 12, these x-intercepts become very, very useful for solving equations, finding the roots of equations, and other things like that. So very, very important stuff that, again, no matter where you go in mathematics, you're always going to be looking at or finding or having the importance of something like a y-intercept and an x-intercept. I usually like just saying y-int and x-int. I like doing that just because it's easy for us, okay? So our x-intercept, that's occurring when the x is 10 and the y is 0. So that's at 10, 0. Our y-intercept is occurring when x is 0 and y is 1,000. There we go. So there's a couple things that you want to take away from looking at intercepts here. First off, the x-intercept is when y is 0. The y-intercept is when x is 0. It's kind of like that opposite land type of stuff, okay? So you want to make that kind of really, really clear, and you want to make sure that that stays in your head. When you're finding x-intercepts, you set your y-coordinate, or you set your function to be 0. Function is 0, right? This is a function of t. H is a function of t. So if we set h to be 0, like the height, which is a function of t, right? Our function is 0, and our time value, well, our x value here, or t value, is going to be 10. In the opposite case, for the y-intercept, we're setting our domain value to be 0, or our independent variable. Equals 0, and our function has a value. So it's very different with that. We don't have an equation for this line, and nor are we going to get one, but that's very important for us when we actually go ahead and we look at these. Now, this is a context question. So we could ask ourselves, what do these x and y intercepts mean in the context of the question, the height of a float plane? And what we should see here is that our y-intercept, again, in the context of the question, kind of says when our plane is going to start descending. Y-int tells us the altitude, or I'm just going to say the height, when the plane starts to descend. And we know it's starting to descend because we have a negative rate of change. The height is going down as time goes on. The x-intercept tells us when the plane has a height of 0. You could say that this is when it's landed, has landed. And this, again, is at 10 minutes, so it takes the plane 10 minutes to do that. If we were to find the rate of change of the descent, all we would need to do is take 2 coordinates and find the rate of change between them. But what's really cool about using our x and y intercepts is that we could actually use the entire y and x intercept to find that instead. So I'm just going to kind of say that to get from the y-intercept down to the x-intercept, we would have to travel negative 1,000 meters. And to get over to my x-intercept, or get over to my other point, we would have to go across plus 10. So let's kind of take this and say our rate of change. And we could do this with any points, including our y-intercept and x-intercept, which is convenient because it's very easy to figure out the distance, or the dependent distance, or the change of the dependent variable between the y-intercept and the x-intercept. It's just negative 1,000. And the change of our independent value from our y-intercept to our x-intercept is the value of that x-intercept, 10. Negative 100 meters per minute for our rate of change. Kind of wild. I like this. X-intercepts and y-intercepts, they definitely mean something in context of the question. So being able to relate that back to the concept, or to the context rather, of the question is very, very important for us to be able to read from the graph and be able to kind of articulate in that. Y-intercept is the height when the plane starts to descend, and x-intercept tells us when that plane has actually landed. And that's in the context of this question. We can use those coordinates to do the rate of change as well. This rate of change will be constant through any 2 points that we do. That's what it means to be a linear relation, in a linear function rather, that we have a constant rate of change. So wanted to show you that one, and we'll cap it off with one more video for this unit.